So when it comes to converging lens questions, this table is very important. You should see this in your school textbook, in, in your notes assessment book. So everything about this table is important. Okay. Now I'm sure it can be a little bit challenging to go through to try to memorize everything at once. Uh, the key is for this is to have to interact with it. So later on, I will show you a software, an app online that you can use for real life interactions, simulations to understand this better. So for this, what you need to understand is basically there are different images formed, okay, based on the distance of the object from the lens. So this is the lens, and the object is placed at different distances from the lens. The reference point, the benchmark will be based on the focal length. Okay, so this part here should be the starting part when you're looking to study this table. So let's say if u is at infinity, infinity doesn't mean that it's forever very far away. It's just at a point where it's so far that you can take it as a very large distance. So infinity means a large distance. At infinity, you would be able to see a small image being formed. How do you construct these light rays is based on the principal light rays, okay, of which I have mentioned to you before how to construct. So later on, I will show you the interactive, and then you'll be able to understand how to construct these light rays. So over here are three things that you also need to memorize. Okay, these are known as properties of the image. And then they always say, write down a property or write down two properties. At most, there are three. Okay? So in your mind, you must take note. And these are the applications also you need to memorize. Okay? Now, you will notice that the O here that represents the object is getting closer and closer to the lens and every time you go down by one level. So that's the pattern. That's the pattern to deduce this table. So you have more than f equals to 2f, more than 2f equals to 2f, between 2f and f equal to f, and less than f. Okay, and the last one is very important. So what are the common questions that can come out? This can come out as an MCQ. Okay, this over here can also come out as an MCQ. I've seen many of the questions that involve these two. So you should pay close attention to these two. All right. Now, let's go to the other one. So I'm going to share this one. So as I mentioned to you before, you should check out this app. Later I'll send to you the link, but I think it should be in the WhatsApp group. So when it comes to uh, converging lens questions, okay, there are principal light rays that you need to draw. So the most common one is this. If you have a principal light ray that is parallel to the principal axis, it will bend and converge towards F, right? So this is the first common principal light ray that you need to know how to draw. So long as it's parallel over here, it will converge towards F. If it's not parallel here, it will not converge. Okay? So take note of that. The second one is this. If it cuts through the optical center, it will not bend. So because of these two light rays, it will intersect and form an image over here. So the small one that you can see here is the image. If you try to drag, if you take your mouse and try to drag the image, it will not be dragged. The reason being is because the image depends on the object. If the object does not move, the image should not move. The intersection of the light rays comes from the object and therefore affects the position of the image. So earlier we were talking about infinity, right? Infinity will be somewhere here. Okay, you get a very small image being formed. And that is used for a, who can remember the application? Telescopic lens, very good. Okay. Then if you are getting closer, okay, you see the image is getting bigger. All right. Now, from here to here, this is your camera lens or your human eye. Okay, everything in this region that is close to your 2F is a camera lens or your human eye. So meaning you say you take a picture using your camera. Usually this is how it works. Okay, the image form will be smaller than the actual object. Very interestingly, the moment you hit 2F, what happens? If you look at it, the candle is 1 square tall. The image of the candle is 1 square tall as well. Same size, image is same size. Okay, this application is what? Do you remember? Yeah, photocopier. Okay. Then over here, if you go between 2F and F, suddenly the image becomes bigger. All right. Okay. So it's important to go to run through this interaction for every single point, every single position of which the object is. Look at how the image changes. Now, what is this application? You go to the cinema, you watch the movie, projector. Okay. Then over here, uh, you should get nothing from is a spotlight. Okay. But the app won't be able to show you this. Yeah. Interestingly, once you go below F, what happens? You'll see dotted lines being formed. These dotted lines are known as fake lines. What's another name for fake lines? Virtual. So these are virtual lines, virtual light rays that are not real. Okay? You should draw this with a dotted line. All right? The candle now is bigger. The image of the candle is bigger. Okay? What property of this image can you deduce? Magnify is one, yes. Virtual. Last one. Magnified. Virtual. Upright. Yeah. What is the application? Yeah. Magnifying glass. So you need to know all of this, huh? Okay. Another nice thing about this app is that you can also convert to diverging. Diverging is not commonly seen in your school questions, so we don't really have to talk much about it, but take note that diverging will always form a virtual image at all times. Diverging is also commonly used for spectacles, glasses. A lot of us are short-sighted, so we will be, or myopic, we will be wearing diverging lens for our glasses. Okay, and that concludes using this simulation to better understand the properties of light through a converging lens.